To example 2. Let's read the question carefully and take out the shape, the objective, and also the constraint. So let's read. An open box is to be made from 16-inch by 30-inch piece of cardboard. So this line here is very important. It's talking about an open box. So this is a box and it is open. You don't have any cover on it. Okay. And then it is made from 16-inch times 30-inch piece of cardboard. So let's draw this. This is a cardboard with 30-inch length and 16-inch width. All right. And the open box is made by cutting out squares of equal size from 4 corners and bending up the sides. So let's do this. Let's draw that you have each of equal size. Let's name it as variable x. Okay. And then cut this part out. And then you are left with this. So from here, just bend at the point that I have drawn here. Bend up. So this is the result. We'll have an open box. Now let's focus on your new length and width. So when this length here is 30-inch, therefore when you cut 2x here, therefore this length here, the resulting length is 30 minus 2x inch. How about the width? Originally the width is 16-inch, and now from 16 you have cut out 2x. So your new width now is 16 minus 2x. And then what is the height of the box? It is this value here, the one that you bend up, which is x. Therefore, this is the resulted open box. Now, let's proceed to read the question. What size should the squares be? So you're talking about x. The question is asking the dimension of x. And let's read further. To obtain a box with the largest volume. This is the objective. You are finding the maximum volume. Alright, so objective number 1 is to find the length x and also to find the largest volume. Number 2, let's define our variable. X is the length of sides of the squares to be cut out. Alright, this x here. And then V is the volume of the box. So number 3, let's take out our objective. So objective is volume. So V is equal to length times width times height. So let's find your new length, 30 minus 2x. Your new width, 16 minus 2x times the height, which is x. So now let's expand everything. So you'll get this equation here. So you can see that your V now is in one variable only. So you are ready to differentiate to find a critical point and to prove it is maximum. Now let's look at the constraint. Let's focus on the width here. All right, so the width here is 16-inch. So if you want to find the maximum value of x, this is 16 divided by 2, all right? Because you need one x here and you need another x here. So the maximum value that you can go is 8. And the minimum value that you can take is 0 because x cannot be negative value. So that is just our constraint. Your x should be from 0 until 8 only. Now, since we are ready to differentiate, let's do that. Let's differentiate. So dv over dx is just power rule. Bring down the power reduced by 1. So this is your answer here. And then to find x, let's equate it to 0. So dv over dx equal to 0. And then you can factorize out 4. Further factorize this quadratic here. Therefore, you can solve 3x minus 10 equal to 0 and x minus 12 equal to 0. And then one of them is 10 over 3, another x is 12. According to the constraint just now, your constraint should be only from 0 until 8. Therefore, we cannot accept x equal to 12. Then we will just take one answer, which is x equal to 10 over 3. Next, let's show that this value of x is maximum. So how should you do this? Let's do second derivative. And then let's find out the value either positive or negative. So let's do second derivative. Let's further differentiate your first derivative. So you'll get minus 184 plus 24x. So since you have variable x, let's just fill in the value of x equal to 10 over 3. So your second derivative is minus 184 plus 24 times 10 over 3. So just use calculator here, you should get minus 104. Therefore, the second derivative is negative, so this is concave down. Therefore, you'll have a maximum point. So now let's conclude. Since the second derivative is less than 0, thus the box has the largest volume when your x is equal to 10 over 3 inch. Okay, so we have proved this. So let's find another objective, which is the largest volume, V. So just copy and paste the formula for V, and then whenever you see X, let's substitute with the value 10 over 3. So just use a calculator. Your answer should be 19600 over 27, and your unit is inch cube because this is volume. Therefore, this is your final answer.